G'day everyone, my name is Glenn. I'm a senior software engineer at HashiCorp, and welcome to Beyond Pester 103, applying a testing mindset to PowerShell. If you have difficulty understanding me, because you can probably tell I am not from around here, or I'm talking too fast, please feel free to put your hand up and just ask me to repeat myself. I won't be offended, it's okay. I'm going to keep questions until the end, so if you can just keep them in your head, that'd be great. So as you can probably guess, this is my third talk on testing PowerShell with Pester. So back in 2018, I gave my first PowerShell testing talk called Beyond Pester 101, Applying Testing Principles to PowerShell, where I introduced the wide world of software testing. And interestingly, the concept of why we test. And even after all this time, this definition still holds true, because we test to reduce the risk that a user will experience an unexpected behavior. I looked at the 4 different types of tests. So we had white box testing, which tests how a function works, how it's supposed to operate. We have black box unit testing, which tests the behavior of a function without knowing how it works. We have integration testing, which tests how units interact with each other, and characterization tests, which is used to make changing legacy code safer. I also talked about treating your tests with the same love and care as your PowerShell scripts. So you can use parallel execution to reduce the duration of your test suite, analyzing your test suite to figure out where tests could be removed, using test tiering to reorder your tests so you can get faster feedback better, and lastly, keeping your tests easy to maintain by adhering to the old adage of say what you mean and mean what you say. But I didn't have time to talk about acceptance tests. That needed a new topic. So in 2019, I came back. And I gave the talk Beyond Pester 102, Acceptance Testing with PowerShell. I talked about the need to think differently with acceptance tests because they're very different to unit integration tests. And to help with this, I used the Cynefin framework, which was created back in 1999 by David Snowden. And it's a sense-making device, as in how can we make sense of our own and other systems' behavior. Talked about the 4 different types of acceptance tests. So we had OAT, which asks the question, do I accept that this system is able to be supported as I intended? We have operational validation tests, which asks the question, now that I've deployed my system, can I still operate it and support it the way that I intended? We have user acceptance tests, which asks the question, does the system work for me? Sorry, does the system work for a user? And lastly, compliance acceptance tests, which does the system comply with the regulations that are applied to it, for example, personal information or data sovereignty. I also looked at different testing tools like Inspec and Gherkin, which are kind of outside the realm of plain Pester, but we can leverage these tools for PowerShell in our systems. So it's 2023. We already have great guidance on using Pester. Then I did my 2 talks and some testing principles on PowerShell. But the techniques and tests that I described, they're still quite narrowly focused. I mean, sure, knowing about black box testing and UAT is helpful, but it creates another question, which is what else is out there? All of this software stuff comes under the category of software testing. I mean, what even is a software tester? And how do we apply a software testing mindset to our PowerShell? So do we actually have any software testers or QA people here today? Yeah, didn't think so. So a quick way to find out what people do in a job is to actually have a look at your local job websites or LinkedIn job postings to see what they're asking for. So here's some examples of some that I found, like designing automation test suites, 60% automation, 40% manual, contribute towards maintaining regression suites, ability to write clear and concise bug reports, review and analyze system specifications, regression testing and reporting. Software testing sounds like a really boring job. You just find stuff that's broken, report it, and then find something else that's broken. And much of it's manual, it's not even automated. And it's no wonder people have trouble applying software testing to PowerShell when this is what people think a software tester does. Boring, repetitive tasks to find bugs. But I feel these job requirements mostly miss the point. If you've ever met a good software tester, you'll know there's so much more to them. Good software testers apply a different mindset to their work, a testing mindset. And I think there are 3 aspects to this mindset. So we have creative thinking, problem solving, and exploration or experimentation. So a good tester doesn't blindly go through their checklist because actually writing tests is trivial. We can almost get the computers to do it for us automatically, and if you went to Yarp's talk yesterday, you would actually see ChatGPT generating Pester tests for you. But designing useful tests that add value to your PowerShell is not a trivial process. It requires you to consider many factors before you write a single line of Pester code. How is this PowerShell supposed to be used? Who could use it? What could go wrong? What could go right? What's the chance that someone would do something out of the ordinary? And many of the job descriptions mention run tests, do this, do that, follow that bouncing ball. And even if you're using creative thinking to make these great tests, they make it sound like a button-pushing exercise. But a good tester knows how to problem solve, how to make those great creative tests and apply them at the right time. And they see test failures as a learning opportunity, not something that's broken. And even once you creatively think about these tests and can problem solve efficiently, there's still something missing. Like you can think of the testing mindset as two halves. There's testing for the things you already know, which is like, if I do this thing, I expect this result. And this is where problem solving and creativity thrive. But the second half is for testing things that you don't know about yet. And that requires the exploration, experimentation. It requires a curious mind to think about, I wonder what would happen if I do this. And this is often called exploratory testing, where testers try different things and to see what happens. And they pursue these interesting behaviors. But that doesn't mean testing is completely ad hoc or spur of the moment. It's actually exploring with purpose. Now, I want you all to take note of something here. Nowhere does it say software engineering. There are no mentions of programmers, developers, scripters, IT pros, sysadmins, or any role. And this is why I get a bit annoyed when I hear people say, I'm not a developer, I can't do testing. I'm a PowerShell script, I'm not a real programmer. The testing mindset does not exclude you. And even though my current job title has software engineer in it, I wasn't always in software dev. I mean, my first exposure to testing was years earlier as a desktop support engineer. I had this manual process that sucked. I wanted to automate it because I was lazy and cheap. I didn't want to do the work. I wanted other people to do the work for me. It was just an application in some PowerShell, and then I saw that the actual developers had this Team City CI thing that did automated jobs. It was perfect. I could just run my stuff there. And even better, they used my desktops to actually do it, so I could easily automate the installation of the software. But there was a problem. The devs were whinging about people touching their Team City stuff and breaking things. And this is where my testing mindset kicked in. I questioned the devs more, and it turns out each of those many agents were all different, even though they were supposed to be the same. I mean, they had the classic Word document checklist, but people rarely used it. There had to be a way to make the agents more reliable. So how do you reliably set up a bunch of computers to be the same? I did this for a job. I built tens of thousands of desktops using automated processes. This isn't a new problem. So for desktops, I had written some VB script, because it was this long ago, and PowerShell to quickly check the state of the desktops before we shipped it to them. But those scripts weren't the best. I mean, they worked, but they could be better. And that's when I discovered Pester. I then tried some basic Pester tests. Does this file exist? This is registry value correct? That kind of stuff. And fairly quickly, I had a basic test suite for a Team City agent. I ran that over the whole fleet, and the admin was amazed. Like after that, I easily got my process automated. And then the crazy thing was the admin actually came back to me and asked if I'd be willing to steward Team City usage for developers, which is crazy. I wasn't a developer. I just wrote some PowerShell. I could apply a testing mindset and use some automated testing tools like Pester to help me do my job. Or in this case, get a computer to do part of my job. So some people hear that story and they actually complain that I took too long to automate that stuff. You could have done it quicker. And yeah, it did take too long. It's not the whole truth though. If you dig a little deeper into this, there's more to learn. What I didn't fully appreciate at the time was how much time broken Team City builds cost the developers. So random or intermittent build failures were causing people's hours of lost time. And by writing those and running those simple tests in Team City admin could proactively fix any errors, reducing the number of build failures, but he could also make changes in the future and confidently wouldn't break anything else. Those tests that took me a while to write saved hours of other people's time. So testing isn't restricted to software developers or any group of people. It's just a tool that can be used by anyone. And in my opinion, PowerShell scripters, particularly those that have done any support work, can make very, very good testers. And with the benefit of hindsight, nothing about my story should be surprising at all, because my story is actually old news. There is a lot of research out there which explains exactly what happened and why. Most notably, things like the Phoenix Project, State of DevOps reports, and DORA research. But this also means that us as PowerShell and Pester scripters can actually take the benefits of this research. Who's read the Phoenix Project? Do I know of it? Cool. So this hopefully isn't too new. So the Phoenix Project has the concept of the 3 ways of DevOps, in particular the second way, which is about amplifying feedback loops. In my story, before I came along, developers only knew there was a problem with the build agents when it started randomly failing, which would then cause them the lost time. But after I came along and added the tests, we could get faster feedback about the broken agents. And this then led to the first way of DevOps, which emphasizes systems thinking. So in my case, I could have just done my little piece of the job, but by expanding my point of view and fixing it for everyone, everyone could reap these benefits. In 2018, the DORA State of DevOps report, the researchers looked at software quality and the amount of manual testing work that was out there. Finding elite performers spent about 10% of their time doing manual testing. Low and medium performing teams were spending about 30 to 50% of the time doing manual testing. Clearly showing that automated testing is something that you really want to get into. Even Google knows this. This is in their book, The Site Reliability Engineering, and there's an entire chapter on testing, which concludes with testing is one of the most profitable investments engineers can make to improve the reliability of their product. Testing is an activity that isn't an activity that happens once or twice, it happens continuously. You may have heard of the term shifting left. So shifting left is about building quality early into the software development process. This isn't new. Programmers knew about this back in the 1950s. When you shift left, fewer things break in production because any issues are detected and resolved earlier. Because finding your bugs in your PowerShell is much easier to do when you're writing it, not when you're running it. And especially when that script reboots all of production, which has been done. But if testing has so many benefits and has an entire class of job roles, why do we struggle to write tests? I mean, I hear Pester is hard, it takes too long. You're not wrong, but again, that's not the whole story. An interesting question is, why is it so hard? Why does it take so long? Far more interesting question is, why do some people find writing Pester straightforward? Why is it easy for them? Was it Pester? Pester takes some time, it's got a small learning curve, but it's well within the capability of most people, say to be something else. What if it's the thing they're trying to accomplish? So there are complex scripts which are easy to test, and there are simple scripts which are hard to test. It just seemed that some PowerShell was more testable than others, and that was it. PowerShell that was written in a way that could be tested made it easier to test. But what does that mean to actually write testable PowerShell? All right, so let's take a look at a real example. Let's write a script that disables and removes old accounts from Active Directory. So the script needs to query Active Directory for the accounts to disable and disable them. We need to query Active Directory for the accounts to delete and delete them. Of course, there's always going to be exceptions, so we need to make sure we don't disable or delete those accounts. And we also probably need to log this for the auditors, so we need to output the results to a file. So now we know what the script needs to do. Let's throw it into some PowerShell, and I don't expect anybody to be able to understand or even read this script at all. But just so you know, this script is actually from Mikey Lombardi's 2019 talk, What to Do with Legacy Code. This is a real script that someone ran in production on their systems. So let's just assume that this thing works. Let's try and test it. So first we need our test fixtures. So first we need the domain controller, we need Active Directory, we need some old and new user computer accounts, all before we write a single line of Pester code, because the whole script is all lumped together. You can't test bits of it. What we need to, you need to test the whole thing at once. So writing tests for this script is really hard and takes forever. It is not written to be testable. So if this is an example of hard to test, how can we make it more testable? Well, the first thing is you don't write any code. What we do is actually have to look at what it's supposed to be doing and then think, how could we test those individual pieces? So this is the first point of disabling all of the old accounts. The tests for that particular thing would be if an account is logged in 46 days ago, should be disabled. 45 days ago, shouldn't be disabled. What about deleting accounts? Well, if it's 6 months ago, it should stay disabled. 6 months and 1 day ago, it shouldn't be deleted. If the account's in the exemption list, and it shouldn't be disabled or deleted. And if we do anything, we should actually log it to the file. So that's a real quick list of all the tests. So now that we can actually make our PowerShell prove that those tests work. So the first tip is to split out your code into smaller pieces that do a single thing. And this is more formally known as a single responsibility principle, which is basically a unit of code should only address one concern. You may have heard this is the bash principle, which is where a tool should do one thing and one thing well. And this was the problem with the original script. Everything was in one unit, so you couldn't test it. So we need to carve this thing out into small bits of work. So let's just have a look at the disable process. So step 1, we need to find the accounts we want to disable. Step 2, exclude any accounts that aren't supposed to be disabled. Step 3, we disable it. Step 4, we log it to the file. But the great thing about PowerShell is we have the piping system, so we can just turn this list of tasks directly into PowerShell code. So again, we find the accounts, disable them, exclude, and log. Now this will probably work, but right now we can't control any of the parameters. We can't control how all the accounts have to be, or when they're excluded, or where the audit file is. So we can just add in those parameters into the function. So now we have 4 functions, and each function does a single task. And now we can test each thing individually. So a quick example, here's the test for the get old account function. I'm just going to quickly go through this. So we've got some Pester mocking there. So we've got 3 users. 2 of them are old, 1 isn't old yet. And then we have our assertion down the bottom saying that only the old accounts are returned. So remember, we couldn't write this test for that old script. In fact, let's put them side by side. So that's the old code on the left, new code on the right. Notice how it's much easier to follow the flow of the code on the right. Whereas on the left, you have to read the whole thing and then try and figure out the flow as you go through. Even though both scripts will probably work okay, the more testable code on the right is easier to read and to prove that it does what it's supposed to do, and it's safer to change. So let's change and add code which removes all the old accounts. Process is the same. Find accounts were disabled 6 months ago, exclude some accounts, delete the accounts, log the results to a file. Again, we can convert that directly into PowerShell. And there we go. And again, we can write the Pester test to prove the script does what it's supposed to do. So that's my first tip, which is the single responsibility principle. Break everything down into testable units, which then makes it easy to read and understand. My second tip is to avoid implicit dependencies. So in C#, this is more formally known as the inversion of control, or you may have heard of dependency injection. You can kind of sort of do this in PowerShell, but really PowerShell doesn't have this concept. But that doesn't actually matter. The point of this is to avoid PowerShell functions using or depending on things outside of its own scope, because that makes it harder to test. So again, let's look at our AD script example. This is a snippet from the old getAgedAccounts function. In particular, I want you to have a look at the new account threshold parameter. It's defined at the top there. In the middle, it's used to create a timestamp, and then the timestamp is used in the AD filter down the bottom. Now, this function parameter defines how old an account must be before it's considered to be disabled. The intent here is just to stop newly created accounts being disabled. Now, you may be wondering where the implicit dependency is. Well, it's getting the current date time here. And this one little dependency actually makes testing difficult. So let's imagine the testing setup. We've got the account threshold. We're going to make it 12 days. We set up some test accounts in AD that are exactly 12 days old. We run the tests, and the getAgedAccounts tests fail. Because by the time we've created all the accounts, they've already expired when we run our tests. So why don't we just make the test accounts only 11 days old then? I mean, sure, that'll work today. If we try the test tomorrow, it's going to fail because they're now more than 12 days old. Now, this may seem like a silly scenario, but the point here is we've lost the ability to accurately test the function, and our tests could fail purely because when we ran them. What we want to do is no longer to use getDate from within this function, but instead the function caller should be responsible for telling us what that threshold is. So the new function will look like this. We change the parameter to created after, which is a date time value. We can then remove the getDate call entirely, so it's no longer a dependency, and we can change the filter statement to use this new parameter. So now we can create and test any account we want, and we can pass in the created after with precision that we need for our tests. And we'll get the same test results whether it's days or years after. But there's actually a little bit more to than just precise testing here. The function actually now reads a little bit easier. It's almost plain English, get 8 accounts that are created after this date. So we can actually apply that same reasoning to the code we just saw. So here's our old script. It has the older than days parameter, and instead we can change them to explicit date times, and we get this. So our new parameters are called older than and passed into date times explicitly so that the get old account and get disabled account functions no longer have that implicit dependency. So that's my second tip, avoid implicit dependencies. But again, these tips are not new. The Learn PowerShell Scripting in a Month of Lunches book talks about tools versus controllers. Notice that tools do one thing and tools only accept input only from their parameters. Tool-style functions follow the single responsibility and avoid implicit dependencies, which makes them easier to test. So to circle back to the original question, why is testing hard? The answer is perhaps the code you're trying to test isn't written in a way to make it testable. And this is something I actually have come to learn myself the hard way. I regularly write in many different languages, so PowerShell, Go, Ruby, and TypeScript. And every time I'm struggling to write test cases for my code, if I just took the time to reflect that, instead of smashing my face into that keyboard, trying to get my test to work, I could just write my code that's more testable. So if testing is that beneficial, instead of writing the test for PowerShell code that already exists, what if you write the test first and then write the PowerShell to make those tests pass? So that will be the concept of test-driven development, or TDD, and you're going to hear me say that word many times. There's already some use of TDD in the PowerShell community. Here's Mike Robbins in 2014. Why not write down what you're trying to accomplish in the form of tests, make sure all of the tests fail, and then write the PowerShell code to accomplish the necessary tasks until all of the tests pass. We've also got Rob Sewell in 2017. I approached writing this module with test-driven development with Pester. This means I have to write my test before I write my code. Those blog articles are a little old, almost 9 years ago, so surely that means TDD is commonly used. Does anyone here write their test before they write their code? Anyone? Anyone at all?
Has anyone tried? No.
I'll get there. So as I thought, yeah. Which probably means TDD isn't appropriate for PowerShell. I disagree. Because those two blog posts aren't the full story. I feel that unfortunately TDD has been misrepresented, which has caused us to miss the points of TDD and why it can be a very useful tool. So here are the 4 steps the articles mention. Add the tests. When you run the test, they should fail. You write your PowerShell code, and now the test should pass. But really, TDD actually looks more like this. Step 1, write a test. Unlike before, we're not writing all the tests at the beginning. We are writing a single test, just one. We validate the test that it fails before we write any code for it. We then write enough code to satisfy that one test. And this can be any old garbage PowerShell, as long as it passes the test. And step 4 ensures that all the tests now pass, not just the one you wrote in step 1, just in case your garbage PowerShell broke something else. Importantly, step 5 is refactor. Refactoring means changing your PowerShell code, but not how it behaves, and because that's what our tests ensure. The test proves that even though we change the underlying code to make better named variables or things like that, the code still outputs the same thing it did before, the same information the same way. And then step 6, we repeat that process. But there's still more to learn about this. That loop is important. This is a fast feedback loop, and it's pushing you to make small changes to code. Add one test, make it work. It means we can be focused on a small thing and do it well. It also means if you happen to add new code and fails test in another area, it is much easier to debug. If you've added 20 tests and changed 20 functions and you broke some tests, which one of those 20 changes actually caused the problem? And that feedback loop also means that if you find out something new, it's much quicker to add things. Now, the refactor loop means even though you're writing absolute garbage PowerShell at the beginning, and I'm guilty of that, we are constantly reviewing our code and making it better. We're always adding in quality. And because we're always adding in the test, we can be confident that our refactors are not changing behavior, we're just making better code. An interesting side effect of adding the test at the beginning. You actually got the requirements or the behavior of the thing you're trying to do at front of mind. We're not getting caught up with questions of like, what verb should I use? Should I use a for loop? Should I use this? Rather, rather we focus on what the thing should do, because in step 3, you worry about the how. And even though step 2 is simple, it's actually a really, really good small quality of life check. Making sure that your tests fail before you write code to make them pass. I have been burnt by doing this before. You know, I'll save some time. I won't run the tests. It'll be fine. It wasn't fine. I spent an hour writing code to implement stuff that was already passing. Don't do that. So in my opinion, TDD is not thou shalt write all tests before writing code. TDD is not acting as a blocker until all of those tests are written. TDD is not an end state. There is no, I've done the TDD, wash your hands, bye. TDD is about creating fast feedback loops, and those loops allow you to make changes and validate them quickly. It allows you to focus on requirements, not implementation, because don't bother implementing something your user doesn't need. And TDD uses tests as a tool to ensure we can actually make those changes with high confidence. There's a good but short article on PowerShell TDD by Devin Gleason-Lambert. He looks at the original 2003 book by Kent Beck and how it actually apply to PowerShell, and concludes with, we are 100% capable of doing TDD with PowerShell, no excuses. It's simple and it's a beautiful thing. So I highly recommend you have a read of that article, and if you're feeling really brave, have a read of the Kent Beck's book. It's a thing, it's gonna take a while to get through. All right, so let's see TDD in action. Remember that AD cleanup script we looked at 15 minutes ago? I was actually using TDD in that process then. First thing we didn't write any code, looked at what it was supposed to do and then how we could test that. Well, that was me thinking about the test or the requirements. I chose to start with the test for get accounts older than 45 days. I then wrote one test. I made sure it failed. I then wrote the code for the get old accounts function and the test would pass. I then reviewed my code and noticed I had an implicit dependency on getDate, so I had to change the function to pass in a different type of parameter. And then I moved on to the next requirement and repeated the process. TDD in action, on stage, if I had one. Add a test, it should fail, write the code, test your pass, refactor, repeat. But this still seems like a rigid process, and honestly, I don't follow this thing exactly either. I think Captain Barbosa said it best. He said TDD is more what you'd call guidelines than rules, which means you can bend them to suit your needs. If you want to, you can do 10 tests at a time. If you're experienced enough in what you're doing and you can make that judgment call, go for it. You may just want to try, a little bit of TDD, just a small amount, and not commit to the whole thing. You don't have to actually write the test in the first place. Even just thinking it through in your head, looking at your code, how would I even test this, can actually help you write better PowerShell, because at least you're trying to make your code more testable. And like I said before, code that is easy to read, so easy to test, is generally easy to read and understand. And lastly, TDD is a tool, which means it is not the best tool to use in some scenarios. If you're just exploring how something even works, there's no point in writing tests. If the code you're writing is truly throwaway, don't waste your time writing tests. Sometimes, this is a bit of heresy here, it is perfectly reasonable to never write a single line of Pester. So TDD seems like something you'd like to try. What test would you write? Where would you even start? And it depends. Every script is different, requirements change. I'm about to give you some ideas on where you could start. So I break my test down into 3 basic categories. First is the happy path. So these tests ensure that your PowerShell works when everything is fine, no errors, no nothing. These tests are always first, because if your PowerShell doesn't work when everything is fine, you've got bigger problems. Next is the sad path. These tests ensure that your PowerShell works when something goes wrong. For example, does it actually handle errors at all? And you could think of these as expected errors. And lastly, you have the weird shit path. These tests ensure your PowerShell behaves in a consistent way when really weird things happen. And I really can't be more descriptive than that. I'm sure you've all just seen weird stuff that happens. Like, what if the network suddenly becomes unavailable when you're trying to query Active Directory in that script I showed earlier? Let's have two examples of this. This was a joke going around on Reddit. A software tester walks into a bar, orders a beer, orders 10 beers, orders a nothing, orders 200 beers, tries to leave without paying, orders -1 beers, tries to order a cat. But you can apply those 3 categories to that list. You've got your 2 happy tests at the top, you've got your 3 sad tests at the bottom, and you've got your weird shit down the bottom there. But let's look at a more realistic example. Remember the get old accounts function? We had to find accounts that were logged in for more than 45 days ago. So we'll get 2 happy pass tests there for 45 and 46 days old. But then we have to consider, what if something goes wrong? Well, what if the account's never logged in? Or what if there's a network error when you're contacting AD? We should probably test for those. And then finally, you get the weird things. What if an account was logged in the future? And as someone who lives in a future time zone, this is not as weird as it occurred, as you first think, okay? So while I can't give you the magic formula for creating tests, starting at these simple 3 categories should give you at least a direction to think in. And this really taps into the exploration and experimentation side of the testing mindset. But what if you didn't want to start with TDD or even unit tests at all? Where should you start then? Well, of course, it depends. But Jez Humble has a great quote in the book Continuous Delivery, which is, if it hurts, do it more frequently and bring the pain forward. And this is also where you should start with tests. The thing that hurts the most and is the most frequent. So remembering I came from a desktop support background, we used to send out a PCs to our users. Those users weren't necessarily in the same building. Some of them were 3,000 kilometers away only by road. If I sent them a PC and it was broken, my users were not happy because it took weeks to get that stuff up to them. So what I did, and it sparked me to start writing PowerShell scripts to ensure that the PC was correct before it got shipped. I tested frequently and I tested early. But what if you manage, servers or even cloud infrastructure for that matter? It hurts when those aren't operating correctly. So it's a good place to start is writing OVT tests or operational verification testing. So those tests validate that the system is in a state that you'd expect. Like for a VM, is it powered on? Does it have pending reboots? Are there any critical services not running? For cloud services, that could be, is the service in the correct zone or location? Is it assigned to a custodian? Or what if you have a PowerShell script that needs changes and it's painful to do so? Well, Mikey's talk here walks you through to do that, and guess what? It uses tests to do that for you. But there's more to testing mindset than just Pester. I like to think of the testing mindset as having a vast array of tools that we can bring to bear on something. And the more testing tools we know how to use and when to apply to a problem, the faster and better results we'll get from testing. So what's some other tests that we can add, other tools that we can add to our mental tool shed here? Has anybody actually used Gherkin before or even know what it is? Oh, cool, there's a couple of people. So Pester has an alternate language called Gherkin. I briefly talked about this in my Beyond Pester 102 talk. But briefly, this is my get old Pester test that I showed earlier, but this is the equivalent in Gherkin syntax. Notice how it's far more plain text and much easier to read. It's actually a really useful tool for acceptance tests or getting non-PowerShell scripters to write the tests for you. It's not a free ride though. There is a lot of background work you have to do to get set up for Gherkin tests properly. Also, Gherkin is only included in Pester version 4, doesn't come with version 5. It'll probably end up as a PowerShell module that you can tack on to Pester. I used to work for a bank, and financial regulations were always constantly changing, and being audited was no surprise. And there's compliance testing tools. One of the older ones is InSpec. So InSpec is maintained by Chef, where it uses more human-readable syntax to specify compliance controls and policy requirements. So here's an example of an InSpec test. You'll see a control definition at the top, then a whole heap of information about the control, and a link to the source document. And then finally you have the actual test down the bottom, which is saying that SSHD should be on port TCP/22. There are some caveats here. Inspec uses Ruby and RSpec behind the scenes, and while Ruby is mostly cross-platform, it has many, many rough edges when it comes to Windows support. Two other languages and testing platforms have been rising in popularity. There's Styra's Open Policy Agent and HashiCorp Sentinel Policy Language. Full disclosure, I actually work on the Sentinel product and its integration into OPA and Sentinel into Terraform Cloud. So have you actually heard of OPA at all? If you heard of the Kubernetes, you probably heard of the OPA. No one? Ooh, okay. So OPA is used primarily as a policy system within Kubernetes, so allowing or disallowing actions based on policy decisions. But it's also been used in a tool called ConfTest. So ConfTest is designed to run policy tests over structured configuration data, be that plain old JSON, YAML, or responses from APIs. So the tests themselves are written in Rego, which is the syntax for OPA. So here's an example from their documentation, which is checking that Azure Managed Disks are encrypted. HashiCorp Sentinel language is designed to be a policy framework to embed in applications, and Terraform Cloud supports applying Sentinel policies in your Terraform configuration. This is that same policy, but it's written in Sentinel language. Now, both products have their advantages and disadvantages, but in both cases, and even for InSpec, they're trying to make it easier to automatically test for policy compliance, instead of making us dumb humans do all the work. And if anybody's done an audit, you'll definitely know that you want the computers to be doing all of that work. I think Daniel Silva, who's actually here, he's got a compliance talk on Thursday, 11 o'clock, so you should go to that one too. Another tool that can be useful to have around is load testing. I don't do it that much these days, but it's nice to know that you can hammer on an API if you need to. My preferred tool for this is Gatling. Has anybody heard of Gatling? Wow, you get all the new tools. It's an open source cross-platform tool, and because I'm lazy, I wrote a blog article on it, so I don't have to remember any of this stuff. So here's an example of me doing a 100 user connections at a time test against my blog. Now, Gatling uses Scala, which is a derivative of Java, to define the tests. I do not know how to write Scala, but I did figure out enough to actually run this particular test. So you can see I've just highlighted the important bits there. We've got the URL that we're going to test is in the top there. In the middle, we actually have the relative path that we're going to hit, and down the bottom is how much load we're going to put onto the blog. Now you can actually do some really cool things with this. You can sustain 100 users. You can actually do 100 and then 1,000 users and drop it back down. You can do some really, really cool things with load testing here. And then Gatling just generates some really nice graphs for you. So in this particular graph where the red arrow is, I found a HTTP error when I was actually trying to get to my blog. But the really nice thing is you can run this on a schedule and you can actually get performance metrics over time. So this is just a small sample of the testing tools out there that you can discover and experiment with. And importantly, one tool is not always appropriate for all scenarios. Pester is great, Pester is versatile, it's powerful, but is not the only tool that you should have in your tool shed. So that's a lot to remember. I'm going to leave you with something hopefully a little bit simpler. So in the movie, Indiana Jones, Last Crusade, Indy's teaching his college class, and he's explaining what archaeologists do and don't do. He says to the class, archaeology is a search for fact, not truth. If it's truth you're interested, Dr. Tyree's philosophy class is right down the hall. Now, you might think that software testing is much like archaeology, searching for facts, delving through the PowerShell, looking for runes for the treasure. In reality, software testing is much more like philosophy. It's searching for truth about your code. In fact, software testing is a specific branch of philosophy, applied epistemology, which is a study of how do you know what you know. And this goes way back to Socrates in 470 BC. That's how long software testing's been around. So how does this relate to testing in PowerShell? It asks two seemingly very simple but deep questions which you as a PowerShell writer need to answer. And these are the two questions I'd like you to remember. Does my PowerShell do what it should? And secondly, how do I know my PowerShell does what it should? If you can look at your PowerShell code and answer those two questions, then you're well on your way to applying a testing mindset to PowerShell. Thank you. We've got some session feedback down the bottom. There is my Twitter and my blog article, and the decks for this is actually up on the speaker deck. I do have a bunch of resource slides that you can just take pictures of right now if you... 3, 2, 1, smile. I can take these off now. And phone's down. And the next one, because you know I've got 2 pages worth. Cool, there you go. There you go. Can you just put his camera down for you? Dare I ask, does anybody have any questions? Yeah, so the question was, it's very important the test should fail before they pass. Yes, you're 100% correct. Because if a test has never failed, how do you know that it's ever true? And I know I'm getting into deep philosophy conversations here. But really? No other questions? I mean, I'm happy to let you go. Oh, yeah. So the question is, do I always write with the TDD mindset? No. There are many times when I'm just going to figure out what the hell this thing does. I'm just going to experiment and prototype. Sorry, I meant specific. I've done it without doing tests first, and I regretted it. Mainly because I got my code working, and then I started writing the test for it, and then I realized the code that I've written is actually really hard to test. Oh, and it's wrong. So if I had have written a test, or even think, this is my point, even if you're thinking about how you're going to prove that your code works, because let's be honest, when you write PowerShell, right, you don't just write the PowerShell and say, I'm done. You write the PowerShell and then you run it and say, oh, it's done. Congratulations, you've just done a test. Kind of. So I'll repeat the question as well. Yeah. So repeat the question is, June Blender, who's awesome by the way, had talked about help-driven development, which is thinking about how would the user experience it before you actually write the code for it. Yeah, that's actually, I didn't touch on this. Ever heard BDD, which is behavior-driven development? It's the same, similar kind of concept, where you have the behavior of the thing you're trying to do is front of mind, and you implement the behavior. And that behavior is driven by the whatever acceptance criteria you have, which is a user should be able to do X with their PowerShell script. I'm happy to let you go now. Thank you very much.